And let us talk Earth satellite under science and technology. Space technology, satellites, orbits, and satellites also called spacecraft. Now, the satellites, so-called the Earth satellites, one is the natural, and Moon is the natural satellite of the Earth. Next now, artificial satellites, and the orbit of the satellite around the Earth may be circular or the elliptical. And satellites are the objects that revolve around the Earth, right? Okay. In the plane of the equator or from north to south, right? In the polar plane. Next come to, so just told you, Moon is the natural satellite of the Earth, and more facts about the Moon as the satellite of the Earth. Say the orbit. Orbit is the near circular, must remember. Orbit is the near circular. Time period is so-called 27.3 days, and this is nearly equal to the time period of the rotation of the Moon about its own axis. Okay. Next. Now, so-called the satellites revolve around the Earth, and the planets revolve around the Sun. The two motions are almost similar. Just see again. The planets revolve around the Sun, whereas the satellites revolve around the Earth. And the two motions are similar. And that's why the Kepler's law of motion for the planets around the Sun is equally applicable to Earth satellite, right? Next, come to geostationary satellite. Geostationary satellite encircle Earth about the equator from west to east. Remember, here above the equator from west to east. Clear? Second fact, time period for the revolution of the satellite around the Earth is 23 hours, 56 minutes, 4 seconds, and roughly it is taken to be 24 hours, right? And this is also equal to the time period of rotation of the Earth about its own axis, because the Earth rotates about this. If we see the motion of the Earth around the Sun, what will happen? They see there. So this is the Earth. Earth rotates about its own axis, and also it rotates about the Sun. Both the revolution and the rotation. Revolution around the Sun and rotation about its own axis. पृथ्वी के लिए ये 24 आवर्स हम लेते हैं इसको, which is also equal to the time period of rotation of the Earth about its own axis. Now the height from the Earth's surface is 35,786 kilometers. Remember, height of the so-called altitude of the geostationary satellite is 35,786 kilometers from the Earth's surface, and its orbital velocity is 3 kilometers per second. Remember, these are the facts. T 23 hours 56 minutes 4 seconds, roughly equal to 24 hours. Altitude 35,786 kilometers, and now orbital velocity for the geostationary satellite is 3 kilometers per second. Now, few more points. Geostationary satellites are far away from the Earth's surface. This point appear to be stationary over a fixed position. And next point, need powerful rockets because height of the geostationary satellite is very large, 35,786 kilometers. And that's why geostationary satellites need very powerful rocket to be launched from the Earth's surface. Just to cover the entire surface of the Earth, now 3 geostationary satellites equally spaced are needed. So third point is 3 equally spaced satellites can provide near global coverage. Now let's come to see the uses. Widely used for telecommunication in India. Telecommunication, isn't it? Now, electromagnetic waves. EM waves means electromagnetic. Electromagnetic waves. Right? Now here, the radio waves. The frequency for the radio waves, F radio. F stands for the frequency, and here is the radio, right? It is in the range of 2 megahertz to 10 megahertz. And these radio waves are reflected back from the ionosphere. And what is the height of the ionosphere from the Earth's surface? पृथ्वी सतह से ionosphere की क्या ऊंचाई है? 80 kilometers. तो ये क्या है? Radio waves in the frequency range 2 megahertz to 10 megahertz are reflected back from the ionosphere. And that's why radio communication becomes possible. But if you want the television communication, it's difficult because so-called the television waves are of much larger frequency as compared to the radio waves. Radio waves की अपेक्षा TV waves जो होते हैं उनकी frequency बहुत ज़्यादा होते हैं. And that's why वो ionosphere से reflect नहीं हो पाते हैं. So these are reflected by the ionosphere. ये क्या होगा? Not reflected by the ionosphere. Okay? और यही कारण है कि we take help of the geostationary satellite for telecommunication purposes. Next, come to the polar satellites. Say a few examples. India's first lunar probe, Chandrayaan first, examples. Next one, India's first interplanetary mission, and there is a Mars orbiter mission, right? So called the Mangalyaan. India's first space observatory, astrosats, must remember. And so called the PSLV, Polar Satellite Launch Vehicle, C-51, launched by ISRO. These are the examples of polar satellites. Now, the time periods of the polar satellites, so called T 100 minutes, orbital velocity 7.8 km per second. This is the orbital velocity. Next, some more information. Its altitude is 500 km to 800 km. Low altitude satellites. So remember, polar satellites are the low altitude satellites. Height of the polar satellite from the Earth's surface is between 500 km to 800 km. Very clear? Its time period of revolution is 100 minutes. And now this satellite will move from north to south. Move from north to south. Okay. So age 500 to 800 kilometer, low altitude satellite. It revolves from north to south. Time period 100 minutes. And since its orbital velocity is very large, इसका orbital velocity का मान बहुत ज़्यादा होता है. Since VO is large, ये every polar satellite will revolve 16 times per day, almost 16 times per day, right? Now, information received from the polar satellites are used for, say, remote sensing, second one, meteorology, and third one, environmental studies, right? Know more about this. GSLV, Geostationary Launch Vehicle. Examples, GSLV MK second, GSLV MK third. And there are 3 stages. 3 stages की हम बात करेंगे. First stage, solid fuel, here. First stage, solid fuel. Second stage, you must remember it, liquid fuel. And third stage, cryogenic. Remember, low temperature. Cryogenic, area of physics of low temperature, right? GSLV MK second is the 4th generation launch vehicle. Remember, it's the 4th generation launch vehicle. Now come to the PSLV, Polar Satellite Launch Vehicle. Polar Satellite Launch Vehicle, right? Polar Satellite Launch Vehicle. Now, first stage, first plus third stage here, taken together. It is a solid fuel. Remember, first and third. First and third stage, solid fuel, and second and third stage, liquid fuel. So now you can find, say this is the globe, and this is a plane of the equator, geostationary orbit, this one, and this is your satellite. This is your satellite, geostationary satellite in the orbit of the equator, above the equator, at a distance 75,786 kilometers, and now this is the polar orbit from north to south, right? So this is the polar satellites. This is how you can make a comparison between the polar and geostationary satellites, right? So that's all for the day. Thanks for joining the session.